Hey, what's up? What's going on? This is your midterm review. I hope it helps, and I hope you like it. All right, right here it says identify the inflection points and discuss the concavity of each function. So, of course, right here, man, when you see concavity, you're going to think second derivative. All right, so we're going to do just that. So we're going to take the second derivative. So the first derivative here is going to be 12x minus 5, and then the second derivative is going to be 12. All right. Now, notice right here, there's no x, so there's nothing to set this equal to solve. So the point of inflection is going to be none. All right, none, not 0, none. All right, none. There's none because there's nothing. There's nothing to set this equal to. All right, that doesn't exist. Okay. Now, what we're going to do is, well, since there's no point of inflection, what we say is this thing is going to be concave up because this is greater than 0. So this is greater than 0. Because this is greater than 0, that means concave up. So how do we define it? Since there's no point of inflection, it doesn't stop. It concaves up infinitely. So we're going to say negative infinity to positive infinity. All right, so concave up, negative infinity to positive infinity, and point of inflection, none. All right, over here, all right, let's start by, again, doing our derivative. So 3x squared minus 8x minus 3. And then our second derivative is going to be 6x minus 8. Now, we take this, and again, we're going to set it equal to 0, okay? Set that equal to 0 this time and solve for x. So add 8 over and divide by 6. That's x equals 8 over 6, or 4/3. Now, I'm going to use the wiggle line test, all right, to determine if this concave up or down. Oh, by the way, this is our point of inflection. Point of inflection, x equals 4/3. All right, so that's part of it right there. There's our point of inflection. Now, I use the wiggle line test. So 4/3 is about 1.333, whatever, right? 1 1/3. So I'm going to choose a wiggle line, so I'm going to go 0, right? That's less than 4/3. And then I'll go 2, okay? So I'm going to test those values. And I test them inside of the second derivative. So I put second derivative of 0, so 0 minus 8 is negative 8. So that's a negative, which means concave down, right? And then right here, we test 2, right? So that's 12 minus 8 is 4. So that's greater than 0, so that's concave up. So that means we have concave down from negative infinity to this point of inflection. Negative infinity to 4/3. And then we have concave up from 4/3 to positive infinity. All right. So point of inflection and concavity. All right. Let's see what we got here. It says locate the absolute extrema of the function on a given closed interval. Use a second derivative when applicable. All right. So right here, when we think about absolute extrema, we're thinking first derivative. All right. So we're first going to find our first derivative. All right, which is going to be 3x squared minus 27. All right, and now what we need to do is set this equal to 0. And we're going to solve for x. So add over 27, divide by 3, that's 9. And then when you square root both sides, x equals, don't forget, whenever you square root both sides, you inherit the plus or minus, so plus or minus 3. So these are critical points right here. These are critical points, all right? What we're going to do with these critical points is we're going to use them on our wiggle line, okay? We're going to use them on our wiggle line. So we have negative 3 and 3. We need to test lower than negative 3. So, oh, actually, no, we don't. We just need to test between 0 and 7. So 0 is in between these two, right? And 7 is above. So we just need to test right here. So 0, if I plug in 0, so if I plug in 0, all right, f prime of 0, all right, and I plug it right here. So 0 times 3 is 0, minus 27, negative 27. So that's negative. And then f of 7, plug that in, 7 squared, 49 times 3 minus 27. That's great. That's positive, right? We know that's positive. All right, so that's positive. Again, that's larger than 27, so it's positive. So that tells me that I have a minimum right here, all right, because I'm only looking between 0 and 7. So that means this is a minimum. So we have an absolute minimum. Absolute min at x equals 3. All right. Now, if you wanted to actually find a point, it would be 3. Plug it into the original. Plug it in right here. You get 3. Negative 54. All right. You can just put that in your table, y equals table. But absolute minimum at 3. Okay. Same thing over here. All right. We need to take the derivative of this one. Let me move over because this one's going to need a little space because I got to do substitution. So I'm going to let f of u equal the outside function. So this to the 2/3, u to the 2/3, and I'm going to let u equal t minus 3, the inside function. So f prime of u equals 2/3 u to the negative 1/3, and the derivative of u would just be t. Nope, t to the first becomes 1. So it's just 1. Sorry about that, small mistake. Just 1. So now, remember we plug u back in. All right, 2/3 times t minus 3 to the negative 1/3 times 1 is still just that. So I'm not even gonna multiply by that. But, well, yeah, I'll leave it there. Times 1 would just be that. So anyway, f prime equals 2/3 t minus 3 to the negative 1/3. All right. So again, I'm gonna punch this in our calculator because we need to do the wiggle line. Well, nope, I need to set that equal to 0 and solve. So what I'm gonna do is let me go to my calculator real quick. All right, 2/3 times t minus 3 or x minus 3 to the negative 1/3, and then I'm gonna graph that. And then we just need to do a wiggle line test. It doesn't look like, let me see. Sorry about that. Zoom. Option 0, zoom fit. There we go, there's the actual graph. So it doesn't look like this thing crosses the x-axis at all. So we just got to find the absolute maximum between -4 and 6. So I'm going to do the wiggle line test again. All right, I don't need this. So here we go. Let me set this equal to 0 real quick and just solve it. So if I set this equal to 0, multiply by 2/3, multiply by -3 is still 0. Add 3. All right, so you end up with t equals 3 because if you multiply by 2/3 on both sides, right, or 3/2, sorry, right, that cancels. So t minus 3 to the negative 1/3 equals 0, right? That's still 0. So now if I multiply this, or if I raise both sides to be -3, and the reason I'm doing this is because I want to clear out this exponent. All right, I'm still left with t minus 3 equals 0, and then add 3 over, you get t equals 3. So there's our critical point. So now if I did the wiggle line test, right, all right, if I did the wiggle line test, all right, we got 3, and then we have -4 and 6. So if I plug in -4 right here, well, I wrote all over it. So let me rewrite it real quick. And really, you know what? I'm not even going to do that. Let me just go to my calculator. I forgot I got the function right here. So let's go to the table. So at -4, it's negative, right? And at 6, it's positive. You see it? -4 is negative, 6 is positive. So this is negative, and this is positive, which means that this is an absolute minimum because it does that. Negative, positive. So absolute minimum is 3, all right? Or x equals 3. Absolute minimum at x equals 3. All right, but I did a lot for that problem. Probably didn't have to do all that. All right, anyway, right here it says sketch a graph of the function having the following characteristics. So let me do my best impersonation of a graph real quick. 4, 0. So 0 and 1, 2, 3, 4. All right. So let's look at what we got here. They tell us, right, that f of 0 and f of 4 equals 0. So these are zeros or x-intercepts, right? X-intercepts. So f of 0, there's an intercept right here, right? Because 0, 0, right? That's x, that's y, right? 0, 0, and then f of 4, again, that's x, that's y. So f of 4, 1, 2, 3, 4 is 0. So there are 2 points right here, x-intercepts or zeros or roots. Now the first derivative, remember the first derivative is our increase or decrease, all right? And in this case, f of 0 is less than 0. That means this is a decrease, all right? Decrease, so either something like that, right? Or something like that, right? But since we're going to this point right here, there's a decrease where x is less than 2. So we're going to this point, 2. So somewhere on 2, right, somewhere on this axis, there's a decrease. So from this point, there's a decrease happening like that, all right? And then right here, f prime of 2 equals 0, all right? Well, again, that means right here, when the first derivative equals 0, there's no slope, right? There's no slope. So there's a point here, somewhere on this along this scale right here, this x value. There's a point right here, all right, where the slope is 0. It's not increasing or decreasing. It's just a point. Or a minimum. This would be a minimum since we're decreasing to it, all right? Or it could be a maximum that turns. But given that there's a point there, it's probably going to keep going. All right, so the slope is 0. Now right here, again, the first derivative is increase or decrease. So this case is greater than 0, so it's an increase. So we have the increase where it's going up, right? Up like that or up like that. Since there's a point here, it's going to go up like that, right? And then the second derivative, this right here tells me that it's greater than 0, so this means concave up. All right, so this means concave up, which is this whole graph. If you draw it all the way out, concaves up like that, all right? All right, a farmer wants to construct a rectangular pig pen using 100 feet of fencing. The pen will be built next to an existing stone wall, so only 3 sides of fencing need to be constructed to enclose the pen. What dimension should the farmer use to construct the pen with the largest possible area? So first of all, this is a rectangle, right? That's a rectangle. So we can go ahead and say area equals length times width, all right? Or in our case, since we're using x times y, we're just gonna say x times y, all right? Area equals x times y, length times width, all right? So we're gonna say this is the length, and we'll say this is how wide it is, cool? Length, width, all right? Now, this is going to be our primary, okay? Our secondary equation tells us and we base it off this. This is going to be 100 feet of fencing. This totals 100 feet. So if I have x and x, I'm going to say that's 2x plus y is going to use 100 feet of fencing. So remember, our first step here is we're going to solve for y. So subtract 2x to the other side. Y equals 100 minus 2x. Now, I take this, now that I know what y is, we're going to plug it into our primary. So area equals x times 100, because this is y, I substitute for y, minus 2x. And then we simplify that by distributing the x, so 100x minus 2x squared. All right. Now, once we simplify this, we need to go ahead and find our derivative, all right, because this is our optimization right here. So we have 100x, the derivative of that is 100, and the derivative here is going to be negative 4x. Now we take that same equation, set it equal to 0, right, and solve for x. So I'm going to add 4x to the other side, so 100 equals 4x, and then divide by 4 on both sides, and we get x equals 25, okay? Now that I know what x is, I go back over here and solve for y. So if I plug it in right here, you get 100 minus 2 times 25. Well, that's 50, so 100 minus 50 is going to be 50. So y equals 50 right there, all right? All right, next example here. So for this example, it says, a rancher wants to construct 2 identical rectangular corrals using 300 feet of fencing. The rancher decides to build them adjacent to each other so that they share fencing on one side. What dimension should the rancher use to construct each corral so that together they will, I believe that's enclose the largest possible area. All right. So let's do a couple things first. All right. We got this big rectangle, but we need to section this thing off. So I'm going to call all these shorter legs X, all right, and all these longer legs Y, all right. Now, that will give me 4x plus 3y, okay? And that should equal, how much fencing do we have? 300 feet. 300 feet. Let me change the thickness of this. I don't like that. So there we go. I had to change that. But anyway, oh, and then it's still a rectangle. So x times y, area equals x times y, or length times width. All right. So again, let's isolate y like we just did. There we go. So we have minus 4x, and then divide by 3. All right, minus 4x divided by 3. So y equals 300 minus 4x divided by 3. So now we do the same thing. We plug that in over here. So we have area equals x times 300. Actually, I'm going to simplify this. 300 over 3 minus 4 over 3x. So this reduces. I'm going to distribute the 3. And by the way, 300 divided by 3 is 100. So distribute the x. That's 100x minus 4/3 x squared. So I just simplified this, guys. I distribute that in and then reduced. Now, we're going to find our derivative. All right. So this will give me 100. And this will give me 4 times 2 is 8. So 8/3 x. Now again, we're going to take that 100 minus 8/3 x and set it equal to 0. And then add over 100 equals 8/3 x. Add over 8/3 x. So now it's positive. And then to get rid of this 8/3, I'm going to multiply by its reciprocal. So 3 over 8. Oops, 3 over 8. I don't know why I'm doing that. I can just move this down. Sorry, y'all. Multiply by the reciprocal again. Oops. Good night. All right, so multiply by 3h on both sides. That's 300 over 8. And 300 divided by 8 will give me 37.5. So x equals 37.5. So now I go back over here and I plug that in. So 300 minus 4 times 37.5 divided by 3. Punch that in my calculator. That's 150 divided by, so 300 minus 150 is 150. 150 divided by 3 is 50. So y equals 50. So x is 37.5 and y is 50. All right. Right here, page 2. It says find a positive. Hold up, let me flip. I can't read from here. I don't want to keep moving it. Find two positive numbers with a product of 12 and the sum is a minimum. All right, so this time you got to swap it up a little bit. Find two positive integers. So x and y, the product is 12. X times y is 12. Then we're going to say the sum, s, I'm going to represent the sum equals x plus y. That's going to be a minimum. All right. So what we're going to do first is isolate y again. All right. This time, instead of isolating y over here and plugging it in, since we're looking for a minimum. The other time, 2 times, we're looking for a maximum. Here we're looking for a minimum. So we're going to divide by x on both sides. So y equals 12 over x. So now that y is by itself, I want to plug that in over here.
Students.
So yeah, now we're gonna plug this into our equation right here. So we have s equals x plus 12 over x. All right. So real quick, I'm going to, man, I hate when this happens. There we go. I'm going to rewrite this as s equals x plus 12x to the negative 1. All right. So now we integrate this. So, not integrate, derivative. We take the derivative. So s prime equals 1 minus 12x to the negative 2. So, well, you know what? Before I set this equal to 0, let's do this. I'm going to rewrite this for you as s prime equals 1 minus 12 over x squared. And then set it equal to 0. And now I'm going to add that over. So 1 equals 12 over x squared. Now I want to solve, I added it over. So now I want to solve for x squared. So if I multiply by x squared on both sides, right? Then I end up with x squared equals 12 because that cancels. So 12 is over here and 1 times x squared is x squared. Now I square root both sides. All right. And you get x equals, just so you can see the breakdown, square root of 4 times square root of 3, right? Oh, don't forget your plus or minus. All right, whenever you square root both sides, you get a plus or minus. So x equals plus or minus square root of 4 is 2, radical 3. All right. So now I know what x is. X is positive 2 radical 3 or negative 2 radical 3. So I come back over here. Oh, by the way, we only want, see how it's positive, negative? We only want x equals 2 radical 3. Because it's told it's positive, so we don't want the negative. We don't care about the negative radical. Right there, we don't care about that. We just want the positive. So now I come back over here, and I'm going to do, I'm going to solve for y. So if I take 12 and divide by 2 radical 3, all right, 12 divided by 2 is 6, so 6 over radical 3. Which you rationalize to get 6 radical 3 over 3, which reduces to 2 radical 3. So y equals 2 radical 3. X is 2 radical 3. All right, so why did I write that? X equals 2 radical 3. And y equals 2 radical 3. And you can always check it, right? Like if I multiply those, you'll get 12. Right? 4 times 2 times 2 is 4. Radical 3 times radical 3 is 3. So 4 times 3 is 12, right? All right, so those are your values. Man, struggled my way through that one. All right, right here it says find the closest point of a graph of f of x equals x squared that is closest to the point 7 and 0.5. Round the answer to round the answer to 2 decimal places. All right, so first off, I remember when we first started doing these were a lot simpler because it would be like one of these words 0 and it made it easier to do. All right, it's okay though. You apply the same logic, and we're going to use a distance formula. So if you remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, we just really need to focus on this portion right here because d squared, we're going to make it d squared equals that. So if we go x2 minus x1, well, x1 is going to be 7, all right? Now, we're going to square that, okay? And then plus, now, before I do the next part, right, if you remember, f of x is y, all right? So we're going to say our secondary equation is y equals x squared. So we're going to let y, since y equals x squared, we're going to let that be y1. And then y2, of course, is going to be 0.5 in our point right here, so 0.5. And square that. So now, what we got to do is FOIL this. So that'll give me x squared minus 14x plus 49. And this one, if you FOIL this, x squared times x squared is x to the 4th. And then x squared times 0.5 is 0.5 x squared plus 0.5 x squared. So that'll give me, or minus, sorry, that'll be a minus, negative minus negative. So negative 1x squared. If you got to FOIL this out, write it out twice, and then, FOIL it. All right, you FOIL that. And then negative 0.5 times negative 0.5 is actually going to be a positive 0.25. All right, and then I'm going to simplify this so you have x squared and x squared cancel. So I have x to the 4th minus 14x plus 49.25. It's 49 plus positive 0.25 is 49.25. Anyway, this is our equation. All right. So now I'm going to integrate this. So when I integrate this, I'm sorry, this is just f. Not integrate. I don't know why I keep saying integrate. I think that's what we've been doing. So when I find the derivative, I get 4x cubed minus 14. All right. So then we take that, set it equal to 0, add 14, divide by 4. So x cubed equals 14 over 4. Which reduces to 7/2. So anyway, if I cube root both sides, I get that, the cube root of 7 over 2. That doesn't simplify. So x equals the cube root of 7/2. And the directions tell us to round to the 2 decimal places. So that'll give us 1.52. So now I go right here, and I'm going to go y equals 1.52 squared, and when I do that, I get 2.31. So there's x, there's y. All right, let's see here. F of x equals 3x squared plus 5x minus 12 is continuous on the interval 0, 1 and differentiable on 0, 1 according to the mean value theorem. There are at least 1x equals c in 0, 1, at which f prime of c equals blank. Find f prime of c and c. Okay. So, if my mind serves me right, what I first need to do, step 1, is take the derivative. So that would be 6x plus 5. And then step 2, we substitute c in place. So this is f prime, then f prime of c would be 6c plus 5. Now, step 3, we need to find the slope, the average slope. In order to find the average slope, I need to take these intervals right here and plug it in to the original. All right, so I first need to do f of 0. All right, so f of 0 will be 3 times 0 squared plus 5 times 0 minus 12, and that'll give me negative 12. And then I do f of 1, which is 3 times 1 squared plus 5 times 1 minus 12. And if I punch that into my calculator, I'll get negative 4. All right. So now I got 0, 12. So remember, you do y2 minus a y1, and you do x2 minus x1. All right, or vice versa. But that'll give me negative 12 plus 4 will give me negative 8, and 0 minus is negative 1, so we get 8, right? So that's the average right here. This is the average. So now that I have the average, what we do is we take step 2. So step 4, we're going to take step 2 and set it equal to step 2 equal to step 3. All right. So that means I'm going to go step 2 with 6c plus 5 and set it equal to step 3, which is 8. All right. Now we solve for c. So add 5 or subtract 5. Sorry. That's going to be 3, and then divide by 6. 3 over 6 is going to be 1/2. So there's C right there, okay? Now, chapter 5, integration and application, evaluate the integral. So this is implicit. So we're gonna have the plus C at the end of the implicit. So when we integrate this, we go x to the add 1 right here. So 6 over 6, that's 7 over 6. Divided by 7 over 6 plus x, and then we just simplify that to get 6 over 7. It's reciprocal. 6 over 7, x to the 7, 6 plus x plus c. Right here, integrate this, so plus 1 plus 1. So x to the 4 divided by 4 minus 4x squared divided by 2 plus 2x plus c, and that just reduces to 1/4. I like to write it like this, but you know, minus 2x squared plus 2x plus c. Right here, oh, this one requires a little work. All right. First off, before we even do this, let's rewrite this as everything t squared over t to the 4th. You know what? Let's do this. Let's rewrite it like this. T squared minus 3t plus 2 times t to the 4th dx. And so we're going to simplify that. So you got to distribute this. Negative 4. I almost made a big mistake. Negative 4. So now, remember when you multiply, you add the exponent. So that's t to the negative 2, right? 2 minus 4. And then that's 3t, that's 1 minus 4. And then 2 plus 2t to the negative 4 dx. So we're going to integrate that. So when I integrate that, that's going to give me t to the negative 1 over negative 1 minus 3t to the negative 2 divided by negative 2 minus 2t to the negative 3 divided by negative 3. Well, I'll leave the plus there because divided by the negative 3. And now, plus c. Now we just reduce this or simplify this. So this is negative 1 over, move that to the bottom. negative negative becomes a plus. Again, move that to the bottom. So 3 halves, or 3 over t squared. And then positive negative becomes a negative. And then again, move that to the bottom. So 2 over 3t cubed plus c. There we go right there. Now, down here, I'm gonna be honest, this is all calculator work. Alright, this is all calculator work. If you punch this in, hopefully you know how to punch this in by now. But this one here, and you can just check it. This will give you 16. This one will give you 38.45. And this one will give you 9.75. So again, that's calculator work. Hopefully. If you don't know how to do it, man, look it up. YouTube. All right, find a particular solution, y equals f of x, that satisfies the differential equation and initial condition. So right here, f prime, or the first derivative is this, so we need to integrate that. Shoot, let's change the thickness. 1 over 5 x minus 2 dx. So when we integrate this, you get 1 over 5 x squared. So divided by 2, and then you get negative 2x. This reduces to x squared over 10. All right, minus 2x. All right, and then plus c. All right. So now we need to plug that in for x, set it equal to y. So you have 10 squared over 10 minus 2 times 10 plus c equals negative 10. So 100 over 10 is 10 minus 20 plus c equals negative 10. Right here, if you subtract 10 over, that'd be, or right here, 10 minus 20 is negative 10. And if you add negative 10, if you add it over 10 to negative 10, c equals 0. So there's our equation right there. F of x equals x squared over 10 minus 2x. Because c is 0, so right there. Right here, find the cost of the marginal cost and fixed cost. Find the cost function. Good night, I can't read. So dc over dx, that means this is the derivative. We're going to integrate that. 25, sorry. So we integrate that, we get x cubed over 3 plus 25x, all right, plus c. And again, like the problem above, we're going to plug in the x value. So that gives us 3 cubed over 3 plus 25 times 3 plus c, and we set that equal to $108. 27 over 3 is 9. 9 plus 75 is going to be 84. All right, so we have 84 plus c equals 108. Subtract 84 on both sides, and it's going to give us c equals 24. So now we have the function f of x equals x cubed over 3 plus 25x plus 24. All right, for 19 right here, it says find the average value of the function 48 minus 12x squared over the interval -2 less than or equal to x less than or equal to 2. All right, I started explaining this in classes and I didn't do a very good job, man. So let me clarify for you on this video. First off, we need to find 1 over b minus a. All right, and then from a to b, 48. Sorry, minus 12x squared dx. We're going to integrate this. All right. So we end up with 1 over 2 minus a -2. From -2 to 2, 48 minus 12x squared dx. All right. So 1 over 2 minus negative 2, 1 over b minus a. All right. It's going to give us the width of our rectangle. So that is going to be 1 over 4. So you have 1 over 4. And then we integrate this. All right. We integrate this to get 48x minus 12x cubed over 3. And from... Love you too, man. So this gives us from negative 2 to 2. All right, so we have 1/4. And again, you put that in your calculator, right? Like, here, let me just show you. Well, here, let me rewrite it real quick. Let me do something. So remember how this is 1/4 48x minus, that's going to give me a 4x cubed. There we go. So I'm going to put that in. From negative 2 to 2. All right, so we just need to evaluate this for those values. So your calculator will do all your work for you. Instead of putting 4 right here, I'll put negative 4, excuse me, instead of 12, negative 4 x cubed. There we go. So graph that. I just need this table. So negative 4 is 64, and I'm sorry, negative 2 is negative 64, and 2 is 64. All right, cool. So you'll see that we have 1/4 times f of 2 minus f of negative 2. So we ended up with 1/4 times f of 2 was, what was 2 again? 64. Minus, and f of negative 2 was negative 64. So minus a negative 64, right? So that's plus 64, which is 128, and 1/4 of 128 is going to be 32. So right here, 32 is going to be our average value, 32. All right, right here, man, the ball is thrown vertically upwards at a height of 8 feet with an initial velocity of 65 feet per second. How high does the ball go? All right, so, man, look, listen. Remember, you start with acceleration. All right, or the double prime equals negative 32. All right, so h prime, all right, which is going to be, or f prime, which is the integral of negative 32 dx, is going to be negative 32x plus c. All right, well, this time c is the initial velocity, 65 plus 65. So there's our velocity equation, because remember the first derivative is your velocity. And then if we find f, right, which is the height, let's say the height is the integral of this. Then that's going to give us negative 32x squared over 2 plus 65x plus c, where in this case c is 8. So this gives us negative 16x squared plus 65x plus 8. All right, so there's our function right there. So now we need to take that, and then what does it say? It says how high will the ball go? So we just need to find how high this thing will. So if we take this and factor it and really use the quadratic, all right, so negative 65, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, and again, you punch that in, let that calculator work for you, so you get x equals negative 0.12 or 4.2. So we're going to use this one. All right, we're going to use that one. So 4.2. And again, how high was the bar go? Right there, 42 feet. All right, right here says sketch the region whose area is given by a definite integral, and when a geometric formula, then use a geometric formula to integral that equation right there, the integral from 0 to 4 of 5 minus absolute value x dx. So first we need to graph this, 5 minus absolute value of x dx. So I'm going to graph that. If you remember it, you're supposed to graph it first. So clear this. 5 minus the absolute value. Remember, press math, go over and to the right, and then ABS of x. All right, so there we go. I gotta zoom out this thing when it's done. All right. Let's do zoom fit. So zoom 0. All right. So man, I thought I was gonna keep going. I guess it didn't. Here, let me just reset my window. Alright, so I'm gonna go negative 10 to 10. I'm just adjusting my window, guys. You don't have to do this. Alright, at all. I assume your window is in place. I've changed my window so many times. Alright. There you go. Alright, so absolute value. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, cool. So on my sketch here, this action, we got this action. This is so much better than what I would have did. I promise you it is. All right, so we're going to say this is 5 right here. Negative 5, and this is 5. Anyway, what you want to do is, remember on this right side, we're going to draw a geometric figure. All right, so from, where are we going from 0 to 4? All right, so from 0 to 0 to 4, we want to be right here. We're just going to draw a little figure right here. So let me do this. So there we go. From 4. All right, from 0 to 4. So we want this shaded region right here. We want this shaded region right here. So you remember, this is a trapezoid. So now we can solve this thing, because the area of a trapezoid is 1/2 base 1 plus base 2 times the height. All right, we covered this in class. So in this case, area equals 1/2. Right, we got from base 1. So anyway, base 1, right? Remember, if you look at your graph, let me go to the graph, right? We got this region right here. So at 4, we need this point right here. All right, so real quick, let's look at that point. That point is at 4, 1. All right, so 4, 1. Oh wait, I don't even know why I left that. 4, 1. All right, so this is 4, 1. Sorry about that. So I'm sorry, this is 4, 1. Oh my gosh. this point, not this. That's 3. So we actually need to shade in some more of this. There we go. All right, and this is 5, 0, 5. Right? So when we apply it, right, our bases are 5 and 1. All right, 5 and 1. Okay? 5 here, 1 here, right? So let's go back. So we got 1/2, sorry again, 5 plus 1, and the height is 4 because that's the x value right here, 4, going to 4. All right, so 1/2, that's 6. 6 times 3 is, I'm sorry, I'm thinking that's 6 times 1/2 is 3. 3 times 4 is 12. All right, so right here is going to be 12. All right, and then if you needed to check it, man, you could always integrate it and check. All right, if you actually solve that in your calculator, you'll get 12. Okay. We're almost there. For this one here, it says equations are given whose graphs enclose a region. Find the area of enclosed. So this one, we got to graph it. I'm going to do some rough sketches just because the video has gotten really, really long. All right, and I want you to be able to see it. So this one, all right, if you graph it, so of course we want to put in our equations and then we want to graph it. All right, so if you look right here, the red is the 2x. The 2x plus 2 or minus 2 or plus 2. And the blue is that parabola. So the red is the top. All right. 2x minus 2. 2x plus 2, excuse me. And then the parabola will be the bottom. So when we integrate this, all right, we'll go back to our graph here. All right, I'm not going to sketch it because I just grabbed it. So we're going to integrate from 1 to 4. Except this time, we're going to do 2x plus 2 minus 2x squared minus 8x plus 10. Because again, this was the top. All right. So you simplify this. 2x plus 2 minus 2x squared plus 8x minus 10. So that reduces to negative 2x. Negative 2x squared. Negative 2x squared minus plus 10x minus 8 right there. All right, dx. I'm sorry, from 1 to 4. All right, so we simplify this. All right, and then we integrate this. All right, and it's really calculator work. All right, but if you integrate it, remember you can punch that in your calculator right there. Because it's a multiple choice test, so I'm not even going to go through that whole thing. Can somebody do that real quick? You got 9? All right, so 9 it is. So we evaluate, well, here, let me write it out. So negative 2x cubed over 3 plus 10x squared over 2 minus 8x from 1 to 4. And you evaluate f of 4 minus f of 1. You get 9. All right. All right, so for this one, and this one's already done for us, it's just a visual, right? We got this equation right here. We got this shaded region. So first of all, let's identify our x values, all right? We can kind of see it, but I want to be specific, so I'm going to do x minus 2 equal to x squared minus 4. Alright, so I'm going to move everything to one side. So I got 0 equals x squared minus x. If I add 2 over, that's going to be negative 2. Then I'm going to factor that. And when I factor that, I'm going to get x minus 2, x plus 1. So x equals 2 and x equals negative 1. Now, for the top right here, we got this red one is the top. So x minus 2 from negative 1 to 2. We have x minus 2 minus x squared minus 4, which we can simplify that as x minus 2 minus x squared plus 4. So we can now, any like terms? Well, we got the constants right there. Negative x squared minus, no, plus x, sorry, plus x minus negative 2 plus 4 is negative 2 dx plus 2 dx. So now we integrate that, we get negative x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 2. And we evaluate f of 2 minus f of 1, negative 1. And when we do so, equals 4.5. All right, hey, y'all chill out. So we got 4.5 for this one. All right. What we got? 25 and 26. 25. All right, we got to graph it. I'll go to the right. It's number 24. All right, cool. All right, so for 24, all right, so we need to graph both of those. So x squared plus 2x plus 1 and x plus, well, before I graph it, I need to find the intervals. So x squared plus 2x plus 1 equal x plus 1. Move everything to one side. X squared, subtract x over, that's negative, that's positive 1x. Subtract 1 over, that's 0, right? 1 minus 1 is 0. We factor this, x times x plus 1. So we get x equals 0 and x equals negative 1. So our interval is going to be from negative 1 to 0. Now I'm going to graph it. Alright, so, man, I'm going to zoom in so we can see the region is real small. And the area we need is between negative 1, it's between negative 1 and 0, right? So we just need this region. It's a real small region, right? But the top function is the x minus 1. X plus 1, excuse me. That's the top, x plus 1. So when we integrate this thing, you have to do x plus 1 minus x squared plus 2x plus 1, which gives us x plus 1 minus x squared minus 2x minus 1, which simplifies to negative x squared minus x, right? Dx. So when we integrate it, we get negative x cubed over 3 minus x squared over 2 from -1 to 0. We got to evaluate alpha of 0 minus alpha of -1. So in doing so, you'll get 1/6. Again, you can plug that in your calculator, punch that out. This one right here, and you'll get 1/6. All right. So for this one, let's find our interval. So 3x cubed minus 6x equal to 3x. So move everything to one side. So 3x cubed minus 3x, or if I bring that over, let it be 3x cubed minus 9x equals 0. We can factor out of 3x. So that's x squared minus 3, right? 3x squared 9x. So that gives us 3x equals 0. So x equals 0. And x squared minus 3 equals 0. So x equals, well, x squared equals 3. And then x equals plus or minus square root of 3. So I can already tell you we're going to have different intervals because we're going to have one, before I even graph it, we're going to have from negative radical 3 to 0. And then we're going to add, remember how we did the Kahoot yesterday?
Yes.
We're going to add 0 to radical 3.
Okay, so that's what you do there. Alright, so I had that same.
So now let's graph it. All right, we got to graph this one and graph this one. So I'm going to press zoom fit, which is zoom 0. We should have the whole thing here. Yeah, if you hit zoom and then 0, that's zoom fit. So look, listen, we got this section right here, and we got this section right here. But what I want to do real quick, well, we're straight. I just want to confirm that that intersection right there is negative radical 3. We know that's 0. And that should be radical 3. So I just want to check to make sure real quick. So when, well, no, I don't want to do it that way. No. I'm just going to go back to the graph. I'm going to do second trace intersection. First curve. Would be this one, and the second curve is that one. So that's negative square root of 3 right here. That's it. That's negative square root of 3. So I know that's square root of 3. All right. So I don't necessarily need the y value. I just need to make sure that that was the intersection. Okay. So the top right here, the top is the blue one. The blue one was, so this right here is 3x cubed minus 6x over here. And then this one is 3x. And the top over here is 3x. And 3x cubed minus 6x. Y'all see it? So we're going to do this minus that one. And that one minus that one in the second. So we have here 3x cubed minus 6x minus 3x. And over here, 3x minus 3x cubed minus 6x. Sorry. So simplify them real quick. 3x cubed minus 9x. And this one will be 3x minus 3x cubed plus 6x. So that's positive 9x, right? 9x. So, yo, you can literally integrate this whole thing in your calculator. So we're gonna go math 9 right here, and we're gonna go from negative square root of 3 to 0. And what was that first equation? All right, 3x cubed minus 6x. So that's negative 9x, right?
Yes.
Negative 9x dx plus, and we're going to do it again, math 9. And this time we're going from 0 to square root of 3. And this one was 9x minus what? 3x cubed with respect to x. 13.5.
13.5.
All right. All right, cool. So, all right, one more. Right here. Of course, we need to. Oh, this one gave us our intervals. Okay, so we already know we're gonna work from -1 to 2. So now we just need to. Oh, we just need to graph this one. So we're good to go. All right, so we plug it in, and then we're gonna hit graph right here. We're gonna get a nice parabola. All right, and so we only want the intervals from -1. So from here, -1 to 2. So we only want this region right here. All right, so I'm not gonna sketch this. There's your graph right there. All right. So now we just need to integrate this one. And this one, again, is a calculator punch. All right, but you just integrate this equation literally right here as is. So -3x squared plus 2x plus 11. And when you integrate it, it's -3x cubed over 3 plus 2x squared over 2 plus 11x. All right, forgot my dx right there. And we're going to evaluate it from -1 to 2. So f of 2 minus f of -1. All right. And when we do that, again, plug this into your calculator. All right. And you'll get f of 2, which is 18. All right. And if you plug in -1, which is -9. So that becomes +9, right? Which is 27. But again, you can punch that in, all right, to get 27 right here, okay? So that's it, man. That concludes this video. And hey, I hope it helps. And good luck tomorrow on your midterm.